Woo! Smooth transitions. It says that I'm buffering. Says buffering. Are we buffering? YouTube is not receiving enough video to maintain a smooth streaming experience. It looks kind of smooth. Is it like low res or something? Could be good, could be not good. Dang. Well, I hope. Is this a dog? Are we talking about a dog? Don't know if I'm not fully buffered. Wonder why that would be. Sometimes the internet here is just bad. Maybe I'll try a little speed test or something. Is that gonna be bad? Is that gonna destroy the buffering? Go. Oh yeah, it seems to be alright. I don't know why it's bufferini. Oh dang, that's hectic. Man, anything with the... Sorry, I didn't mean such uplifting music when you're... Anything with the dogs, anything goes wrong, you're just like... I think it was New Year's. Lou and I went... We just went out for dinner, I think. And... it was Guy Fawkes, sorry, yeah. Or New Year's. Whatever it was, people were letting off fireworks, I think. And when we got back, like, Chili was, like, doing this thing where she's like... She couldn't stop swallowing, and, like, we're like, oh no, this is not good. So we kind of freaked out and took her to the emergency vet at literally at New Year's, like at the fireworks. We were just leaving the vet, and I think she might have been barking at like fireworks or something, and then got a sore throat because she was fine. Classically, she was, as soon as we would go get in the car and then she'd stop doing it. We're like, oh, maybe she's right, and then we'd go back in the house and she'd start doing it again. We're like, yeah, those dogs, they'll get you. So yeah, is this stream is this stream actually working? How do I know? Viewers, stream health, poor. Why is it poor now? Stream is fine. Okay, maybe it's a glitch on the analytics. We'll see. Where were we last time? Oh, that's right, I did some stuff. Better sync that. We were doing switches and station filters last time. Yes, we were. Let's see if things work. Do. Oh, yeah, that's on the wrong. Well test. There's going to be some lag. Oh, I did add a thing. New feature, trees. Beep beep. Oh yeah, now there's a plane instead of nothingness in the background. So I made a little tree planting algorithm that does a little sample and tries to plant trees that are not too close together, which is kind of cool. Kind of works. as little, whatchamacallits, things in the way of things. As such, viewers will experience buffering, and even the ability to remove trees. Beep, 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 beep. Isn't that the most incredible cargo maneuver from there to there? Down, 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 down. Otherwise, any interesting dev stuff happening? Boom, 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 boom. So that should switch now. Don't know if it's going to do much, because it's going to keep dropping off. Haha. What happens if we do that? Oh, there we go. Oh no. Now we're going back and forth. Oh, but we have this thing where we can accept all supplies, none. All right. Howdy, howdy. Getting back on the guinea pig game. Trying to think about how I want to approach moving. Oh, right. So they're now creating the animation data that you need to bring in. Or something. Something to that effect. Looking at this, there is a plane with some lighting on it now. But I was thinking of a way to give it like some normal schnormal maps. Some moving schnormal. All aboard!
We're not too sure exactly how we're going to do it, but it's going to happen.
Structured it different in the sprite editor so it's cleaner than the mess. Yes, the mess cleanup is very important. Oh yeah, also yesterday I went through this whole process of doing frustum culling, and you can actually see it doesn't work quite properly. It starts cutting things out on the edges. And also, it's so computationally expensive that it actually slows the game down. So it's faster to render everything in the world than it is to test and see if they need culling, which is strange to me. Oh, could we do? I guess you could have a little thing here, like a little thing here, or even a little thing here. There's something, so I mean it's kind of like equal parts when you make a system and you're kind of just setting it up to get it going, and then later on you're like, oh, okay, this system needs to be better, or you start working with it and you're like, it's not workable, and you go through and the refactor is like you're like, oh man, taking everything apart and putting it back together. It can be so painful at times, but then once you finally get the new system and you're like, oh yeah, Yeah, so frustum culling, I don't know. The implementation was probably bad because it was like, I don't know, it seems like a lot to do. You have to take every matrix, get its bounding box, and then move its bounding box into world space, and then test against each of the 6 frustum planes. And yeah, like it goes from, we're getting 300 or 400 frames down to 140 and rendering less objects, but the instancing itself is so fast that it kind of like everything's instanced, so it doesn't really matter. I mean, maybe there's a simpler way to do the culling, but I don't even know, you know? These are the kind of things, this is premature optimization. Is there anything? Oh, we've got this weird music. I need to remove it from the playlist. Oh yeah, so I had this idea about, right now everything is rendering through the same, this one shader, this one mega shader. But the ocean would be a totally different thing, so. I had this, I kind of know what I want to do, but I don't know if I know how to do it properly, but. Yeah, well, every object, like every flat tile has one draw call, and every container has one draw call, and every station has one draw call. So going through each of them and testing, you know, you could probably do like a, because everything's in tiles, maybe there's a way to do like a level-based culling or something. Like if a level's completely off screen, just do one big box that says, is this level even on screen? If so, draw it, otherwise don't draw it. You probably have to do like some custom thing. But yeah, okay, so I started messing around with this. I haven't actually implemented any of the shader stuff, and I don't really know if I can, but I'm just gonna load up my faithful, trusty program, the greatest of all programs. If you don't have it in your game dev, you're missing out. I don't know if I've actually used this on stream, but whoever this is made by one person. I bought the Steam version. Pixel Composer. It's a rainy old day here in Sydney. Sydney's like trying to have winter, but it doesn't really know how to have a proper winter over here. Okay, 3 new projects open. Okay. Oh, whoa. What is all this? Why is this font so tiny? Interface. Scaling. Oh, well that scales. Has this got a custom font in it or something? Text, middle mouse, bloody blah. Oh, you can overwrite the UI font. That's pretty cool. I don't really want to though. Well, maybe I will. Fonts. What happens if I do this? Does this have to like reload or something? This is going to be bad. Preferences, interface. Anything that lets you change the font is pretty awesome. Okay. Close program. Right, let's get back into it. Pixel Composer. Okay, yeah, this is just using the thing. So this, I don't know if you've ever seen this program before, but especially if you're doing pixel art. How can I show, like, oh yeah, I had this whole, well, what is this? Go away. Open. I wonder if I've still got, I used this to make all the spaceships in Space Game. What did I call it? Where is everything? Pixel Composer 2024. Will this work? Fail the wrong version. Okay, we'll just go for a new file. So I think the way I did it, so it's node based, so it's kind of like it's more like a visual effects program, but it's like a procedural art thing. So you can set the global size of the sprite you're working on. 256. We'll make it 256. And then you got all these nodes. So I got the scatter node, and it's not scattering anything. So we'll make a shape. Draw a random shape. And we'll scatter this into the surface in, right? And we'll scatter less of them. We'll make the scale less. And then you can do things like put in a canvas, right, and make this into the sample surface. And then it's got a full drawing thing over here. So say this is like a mask for where I want to sample stuff, where I want to scatter things. And it doesn't look like it's scattering anything. We'll scatter stuff, and it'll scatter them in that region. I'll let them like rotate as well. Rotate, and then the color. I can get it to cause a random color or whatever. Thanks. Bear with me. Put it into a mirror modifier. Modify it on, and all of these things have like little widgets and stuff. So you can go back to the canvas. Is this control? Is there like a shift or E, erase? So I just like draw out a shape that I thought looked cool, and then the scatter, you can mess with the seed and it will, is this like hard to see? Oh, I need to set up this, sorry. This is a really slick demo. We'll go to the scatter. You can mess with the seed. This isn't a very cool shape, so you can mess with the seed of the shape and get some different shapes going or something. Okay, so this kind of, doesn't really look like anything, but you can even have the other thing up. Oh, perfect, little spaceship. You can have a preview up and be working on another node or whatever. Okay, this isn't for this game, but I'm just showing you this software because I'm a little bit excited about it. And then there's like bevel modifiers. You can make different types of bevels. Scatter more objects to get some stuff going, some interesting shapes going. These are better, this thing's better when you have unlink the scales and you can do like different, oh, why is this? This is on some weird mode, constant random range. Yeah, we want random range. And this, is this random range as well? Oh yeah, there we go. Perfect. Scatter full image plus tile area. Map. That's the one I want. Isn't this what I want? Distribution map. That's what it was. Okay, now it seems to be. Go away with you. Draw a ship that looks like this. Perfect. Scatter less. I don't know why it's cutting out. Both sides. Oh, yo, there we go. Give me some ship, man. We'll have less pieces. Then it's also like got an ability to do like colorizing. So you can create like a gradient. And at each point colorize the ship however you might want it to be. And it uses the, black to white gradient to create some interesting stuff. White, be gone. Oh, I did make it gone. Obviously this one doesn't look amazing, but yeah, this is Pixel Composer, and you can do like this normal lighting. You can generate normal maps, but what I'm saying is this is obviously a real specific thing I'm trying to do. But all of these tools are pretty interesting for just general sprite work anyway. So this wants the, what does this want? What are these things called? Normal light, surface in, normal map. So why is it not doing anything? Type, sunlight. Oh yeah, there you go. This is not exactly what I was expecting. But you can take all these nodes and cook them down to $10. You can take all these nodes and cook them down to a tool with, like, you can build your own tools out of and put your own inputs and stuff in there. And there's all this math in it. It can do this, you can do like range-based things. Or is it like array range? And then go into, you can click on the seed, make it visible, send this in, and it'll do 10 different seeds. So now you've got an array of 10 different things. I mean, they all look pretty bogus. This random shape's not doing me any favors. I was like imagining ways to generate, like, I think, where are the ships that I actually made? That ended up with a pretty cool tool of stuff, but starships, ships. I think this is all kind of old stuff. Beyond Nexus, Dev, C, Beyond Nexus, Res, Sprites, Player. Oh yeah, making these little bug dudes and stuff. You can get pretty. You can add like highlights and things and make them look like they're metallic and whatnot. Enemies, I think. Oh yeah, these are, you've probably, if you've seen the devlogs on that. So you can make kind of like interesting things. Anyway, none of this is for daisy trains. But daisy trains, what I was thinking of is I wanted a noise map for the ocean. maybe 2048. Because this can generate tiling noise. If I put a transform down and move it, but also say tile it. You see it tiles perfectly, which might be nice for something. But also, yeah, it can be very useful for, also it's got a full animator, and you can do, like, it's got some built-in animation effects and stuff. Like you can do text, you can do 3D. It's got simulators. It's really full on, Hey bro, let's have a look at Pixel Composer. See if it's got any sweet demos in there. Yeah, especially if you're doing like work that's requires you to make a lot of stuff. I just think there's so many tools in the toolbox. Like doing this manually and yeah, it's got a little 3D thing. Most of these are kind of old demos. Oh yeah, he's got some added stuff. Look at that, he's making little destruction physics and stuff. Particle systems. It can create sprite sheets. It can do packing and things like that. It can do exporting JSONs and whatnot. Yeah, it's a pretty cool tool. Especially if you're working in 2D, I think. Anyway, that's me enough shilling for that guy. So what I thought was, well, this is the thing. There is no limit to the size of this is a 2K texture. So everything will work. It just may work a little slower. But I've used it for higher res stuff like this. This texture mask, right? Well, this color thing got me thinking. Last night I was playing around on a laptop. I was like, okay, so say we make a grayscale and we make it kind of large. And then we make a new RGB image out of these, and I'm only putting the transform here to check that it tiles. And then this one we changed the seed and we iterate it up some more. We put that into the green channel, and then we make another one. It's going to be like a high intensity, high frequency, and then we pack them into an RGB image. Then we can save this. In fact, I already did it, but I'm going to save this one as well. Dev, Daisy Trains, C++. Textures, this Perlin noise tiled. Perlin noise tiled. And then the idea is that well, the idea was, I played around with it in Blender and it kind of works, is to scroll each of these. You split out the channels in your shader, you just grab the RGB ones and you scroll them across the ocean at different rates and at different this is not a shader program, this is a does this have any like I don't know. This is a procedural art program. It's kind of designed for pixel art, but I don't see that you need to keep it restricted to pixel art. Booyakasha. Oh yeah, Olex. We're about to undertake some questionable Oh yeah, Alex, we got, I don't know if you saw, but we got some, man, my TV's always listening to me, eh? We got some instancing going and whatnot. We got some good forward progress on the renderer. Beep beep. Oh, this is in debug mode, so it's going to be slower, but now everything is, every object has got one draw call, which is nice. So we can render 100,000 containers at like 300 frames a second, which is nice. Sweet instancing. Everything is auto batched and auto instanced, whether or not it's a good idea. Trees. So there is this batch info here. There's 28 changes and 1,000 instances. If you implement ray tracing, you get instancing for free. Interesting. Question though, have you used frustum culling? Because I don't know if it's just a dumb frustum culling thing that I got, but it actually makes the game slower. It's just too many bounding box checks or something. Everything is instanced all the time. Oh yeah, but you know what you're doing. That's the big difference. You have some kind of idea of what the heck's going on, which is an unfair advantage if you ask me. Yeah, I don't, if it's like high instance counts, millions of little things, maybe there's some bigger block culling. I was thinking you could do like level based culling, like just big cubes, and be like, is this scene completely out of the camera, then don't render it. Yeah, oh, you got that little top down thing. Yeah, it like frustum culling itself, maybe not even. Like if the camera angle doesn't change, then you can kind of just say how far away something is, right? Now I'm about to do questionable shader things. Genie renderer.cpp. Oh no. Renderer.h. In our shaders, we are going to have a new shader. Ocean shader. Old games use volumetric level stream, using volumes to hide stuff when the player is off. Yeah, the culling I did on Space Game was kind of cool. It's like big tile-based culling, but you still have. Oh yeah, and I managed to like split the world into things that were like within possible view of the player by putting them in and out of these hash maps. That was kind of, so you only ever iterated on what was possible to be simulated or something. I haven't actually, everything's running on one shader right now, so I'm a little concerned. A, I don't know much about shaders, and B, I think I'm gonna have to just do the ocean as a different case altogether, because it's not really an instance. And the instancing thing just hard codes uses the PBR shader. So when we load this, the ocean plane, maybe we need to set, at what point in load model does it assign a shader? I think all this draw model stuff is dead now. Materials dot resize. So material. So this map doesn't ever have its shader set. We never actually use this shader thing. It's just stored there for material, shader ID. Find all. Yeah, GPU culling on the vertex shader, right? Super high. I don't even bother to implement LOD systems. Yeah. This is the... Oh, okay, so I never actually assign a shader anywhere. I guess we don't even need this right now. We'll just hard code it. The problem is, oh yeah. So on the game, I've got this little thing where we just draw the ocean with these little debugs. This is the beginning of this is all the stuff needed for this. So actually I don't want it to be in the renderer. I've only got this add model to the model queue. I don't actually have a list like straight up draw. Render frame inits the render batch. And then the draw render object draws that. I just kind of want to draw render object. I guess this draws a single object. And I can use that. Instead of add model to render, it'd have to be after begin frame. We got render frame. Render, draw, renderer, oh, it's graphics. I see. Graphics, draw, render object. I guess we can say ggame models.ocean plane dot render object IDs 0. So that's actually where it's stored in the render object. ID equals that. And then we need to get the object. Render doc. Okay, thanks for the video. I probably have a very basic question. I want to make games in Unity, but I don't know where to start. Some people say to learn C# right away, while others try remake games from tutorials. What I would recommend, I went through this exact process, and I spent many years trying to get my head around C# and like, I think the thing is like Unity itself as a program is kind of doable. But if you don't have the coding experience or the knowledge of how code works and stuff, I actually tried for many years to get C# through my brain, and it just wasn't working because I didn't really have a fundamental grasp of like what it is we were trying to do. And what helped for me was to download Game Maker and do a set of tutorials there where they make like an asteroids game, and they do it in their little visual scripting and in their Game Maker language. And the person who teaches that is really good. They teach some good fundamentals about like what it is you're doing with the loops and just the general basics. And then from there I was able to like try and port that into Unity with C#. I think C# is a good language to get started with if you're new to stuff. If you have no idea what's going on, then yeah, eventually it's good to learn C, though. Render doc. What's the name of the program you used in the previous stream? It showed the draw calls. Render doc. Yeah. Yeah, okay. Okay, these guys are saying start with C. And I think, like, even Raylib and C, and just some... C's good because it doesn't let you do anything. It doesn't let you, like, multiply vectors together. It doesn't let you do anything fun without knowing how it works yet. Cheers. Good luck to you too. Ocean object equals genie renderer genie renderer dot objects object ID, and that can actually just be ocean ID. This is a render object. Is that what that is? Okay, so we can get the render object. We can draw the ocean object, but we can't actually just draw straight up because we don't do any of this init render batch stuff. And this is kind of, we're just gonna have to do this manually, I think. Because we don't know what the particular uniforms are that we want. Which is going to be interesting. So how do you... C# nowadays is a complex language, yeah. I don't know, what do you think, like... What do you think about the idea that, like, when you start learning game dev and you use something like C# and C# just kind of lets you make a list and, you know, insert an element and remove an element and multiply vectors, and you can just do whatever you want. Maybe Unity helps with that. But do you think it's better to know, to be concerned about what's going on first before you start having the ability to do all these things? Because then, like, the way I learned it, I start with C# and it's like just do whatever, and then you go down to like C++ or C and you're like, wait, you can't just do stuff. You have to, like, first thing was just Pascal. Pascal sounds like a lolly. Udemy is too big, it destroys your context too much. Yeah, I tried a few Udemy courses, and it's just hard to really... People say, we're going to make this big thing, and you're just like glossing over so many things. Actual education just takes time no matter what, I think. We will do this. We will have to do init the ocean shader gl use program. This should probably be on the shader itself. How would you I don't know how to think about this. Like, I'm trying to keep the context of the engine just has tools to do stuff, and the game, it doesn't know about the game. So if I want to do something very particular, like set an ocean shader which has a particular set of like uniforms and stuff, then I guess you could just make these like Raylib does. It does like shader set value or whatever. Maybe you just make these a little more user friendly. Yeah, do some VODs. Yeah, the stuff you've been working on is very interesting. We want the let's just get the renderer. Renderer reference renderer equals the genie renderer. Use program renderer.shaders.oceanshader.id. And then bind the vertex array. The ocean objects dot mesh dot VAO. What's wrong with you? This is a pointer, that's why. So we can't just call this, we'll just chill out a little bit. Then we need to, const material ref mat equals, I mean, what are all these IDs? Is that actually a thing? Do we need the mat? Oh, I guess that's set in the that must be set in this. Textures load image. Yeah, must assign that. Okay. So we don't really need the material per se. We just need to we're gonna need a shader. Why have I got so many shaders? I only use one. Ocean.vertex shader. New file ocean.fragment shader. So looking at the PBR vertex shader. Corrected. This is where the AI corrected me. Hey, we've corrected your shader. We don't really need that line there. Believe me, I needed a lot of help with this. 460 core. Layout, location equals 0, in vic3, a position. We're going to need the position. We're going to need the normal, the text coord, the tangent. I don't know whether the A color is this used. That's just we're sending out the color, not the color tint, but the vertex color. I don't think that matters. These are probably important. Probably don't need that note. I guess we do. Dum dum dum. NVIDIA Insight, is that like RenderDoc but more for NVIDIA? We will need out vic3 frag pos, out vic2 text coord. We will need out vic4 color. Will we? I don't think we do. Out vic3 v10. We're doing this in separate vectors for some reason. Debugging things, but by tangent, bit tangent. Vic3 vector normal. All right. We probably don't need the color tint. We will need the uniform. Oh, here's a question. Is there I was thinking about like doing this model view projection. Projection view. I guess that does need to be separate. Because I was like, couldn't you just calculate the view projection together and send them in? So you're doing it per vertex. Would that even make that much of a difference in this day and age? We will need a view. We will need a projection. And we won't need any instancing stuff. This doesn't need to be as complicated. All we do need the frag position. Frag position equals vec3 model, u model times vec4 a pos 1.0. Yeah, I don't know much about it. I've been getting a lot of help with these shaders. I'm trying to like learn by writing some more stuff. Text chord equals a text chord. That's passed through. We don't have the color. TBN. So mat3 model linear. mat3 u model. And then mat3 normal matrix equals transpose the inverse. This is what you were talking about last time, the model linear, where the normals have to be in a different space. vec3 n equals normalize the normal matrix times the a normal. Okay. T equals normalize the model linear times the a tangent dot xyz. Orthogonalize t with respect to n. I don't know what any of this stuff is really. Normalize t minus dot t n times n. I mean, I know what it is kind of, but I don't really know the math. I don't really, I'm all right with that. At this stage, cross n t. I couldn't write this off by heart or anything. That would be insane. But people will know how. Them normals, yeah, man. I spent a whole day debugging this normal. The normals weren't rendering properly. The whole lighting calculation was like, if an object was rotated, and I was going through all this stuff and I was like asking every AI and looking up all this stuff like, what's going on? It's like, oh, your TBN is wrong. And after a whole day of this, you know, it turned out to be, I had set, when loading textures, I just hard coded them to be sRGB and forgot about it. And so the normal maps were coming in the wrong color space. And then I just switched that to, you know, look it up with OpenGL and it just worked. Oh, wow, gosh, man, come on. V tangent equals T, V bitangent. I mean, can I just make this into a matrix and not have to have all these things? Can we just do out, is it a mat 4? Yeah, like every time there's been a bug it's been something that's not directly to do with the problem. You know, it's something else. I did some dumb thing somewhere, and I had to find it myself. You know, you ask, and it gives you all this information. It's like, you need to re-orthogonalize using this other thing, and I'm like, but do I? I'll just keep these as is. GL position equals U projection times U view times Vic4 frag position 1.0. Okay. What did I do wrong? GL position is an undeclared identifier. Oh, I'm also in the fragment shader, which is weird. I'll put this in the vertex shader, it's probably better. Does it know that I'm in the vertex shader? I thought the file names didn't make a difference. Okay, now let me get into this monstrosity that is the PBR fragment shader and try and pull out some of this stuff. So we don't really need a lot of this stuff. We do need this. We do need, go away. I didn't ask for that. We do need the version 470. Whoa. SLang. Does GLSL work with Vulkan? Is that what the Vulkan? Because I mean, there's like SLang's that new one, eh? Is that like the one that's supposed to be able to be compiled down to any language or something like that? I don't know. Okay, we don't need the color. GLSL is fine with Vulkan. Okay, we will need an outvic for frag color. We will need the uniforms of all this. Lighting uniforms. Shush. And then for the material, we're gonna need, maybe I'll just make these uniforms as well, so we can play with them. Float uniform, float U roughness. And that's all we really need, eh? I guess we could have a uniform Vec 4. Do we need U color? Do we need Vec 4 for that? Let's just do Vec 3 because we don't need. Oh, we do kind of want the alpha, don't we? We'll see. We'll see. Visual code. I know, man. This is the. I got this one. I don't know which one it is. It's enabled. Only one of them worked. At least it works. It was like GSL linter or something. WebGL GLSL editor. I don't know why WebGL one works, but it's the only one that actually gives me any kind of feedback as to if I've made mistakes. I don't think I'll do the debug flags just yet. Maybe we will have our const float high. We do want all this PBR functions and the ACES tone mapping and whatnot. That tone mapping should be used in the frame buffer or whatever, but you know, we're gonna give it, we're doing it the bad way before we can do it the good way. So Vic for albedo equals U color, yeah. That's all we need. Float metallic equals 0.0f. We don't really, we're just gonna say it's 0. Float roughness equals U roughness. I don't know why I've become spacing mad. Okay, so we don't need the roughness map. We don't need to clamp the roughness. We don't need this color masking stuff. You know how they say don't put if statements in shaders? I don't know if you can see that, but I've got so many debug outputs. There's that many if statements. And it doesn't actually make a difference from my very brief views. Obviously you'd turn it off. Yeah, thanks. All right, I'm taking your word for it. Yeah, you kind of, I mean, until like the thing is done, you're gonna have a lot of stuff to help. You need this stuff to work. I mean, I can't imagine ray tracing must be complex. Okay, normal mapping. This is where we want to get. We want a uniform sample 2D noise, U noise. RGB. Right, yeah. I don't know how that, I mean, I watched a video on how branch prediction works and stuff, and I don't get it, but I mean, it seems to be pretty good. I mean, it's pretty good at doing what it does. So what I want to do is like take each channel of that. Oh, this is the problem. Oh yeah, I didn't think about this. Can you, is it possible? I mean, I'm sure it's possible, but can you convert a height map to a normal map in the shader? I kind of didn't think about that. Height to normal map. Convert a height to a normal map. Doesn't seem too crazy. Step equals 1 bump from depth. How to create normals, a height map. Yeah. The other thing I could do is do like in here, actually convert these to normals, but it might. it might mess with the tiling. Normal height, give me some height, doggy. Oh yeah, it kind of works. It kind of looks, why does it look like that though? I guess this is the smoothing factor. Oh, beautiful. Still super pixelated. Oh yeah, which way is up also? It's a little... If I made that RGB, would it help? Not really. I guess... I don't know, can I change... Oh, it's 8-bit RGBA. What if it's 16-bit? Hey, that helps. But then I'm sure if I export this, there is a bit of a line there. (16-bit). Don't worry too much about smoothing. Where's my little transform tool? Okay, there. There is definitely a line there. I guess you could do the thing where you like transform it to exactly half pixel value. 2048 is 0. I mean, and then apply some sort of blur to it or something. Blur. Blur. Is it, where's the like Gaussian blur or something? Blur. It's kind of ruining my thing. It's alright for this one, but it probably... Oh, now we're going to have 3 normal maps. This is going to ruin my thing. Surely we can convert height into normal trivially. This is another height to normal map. Doesn't seem like a lot of code. How to use a height map. Surface normals for a height field. GLS normal maps from height maps 2. Just out of curiosity. What happens if I put this guy in here? Again, we get these normal settings. The blurring will do what to our thing? It will make him too blurry. Yeah. Those little edges will be suckful. Okay. There's a great on CPU branching, what every programmer should know about how CPU... Oh yeah, I think that was the one I was watching. I was kind of watching it with my eyes kind of like... Yeah. Oh yeah. Oh, okay. Yeah. But it was quite informative. It gave me hope that the compiler is pretty powerful in what it does. So let's just start by trying to Vic3 noise large sample equals texture U noise RGB Actually, this is if... I guess we can go noise sample. We just sample the texture. Noise RGB. And the text chords. Dot. Maybe we get all 4. No, we get 3. Dot XYZ. So this says to then normalize this, but this is not a normal map yet. This is just black and white. Yeah, hopefully, sometimes I just watch things and just hope that one day it creates little understanding. F32 noise large equals noise sample.r. Medium equals noise sample.g, and small equals noise sample.b. Doesn't like this. F32, all right, because we're not in engine, we're in here. And then I guess we could just straight up draw the, we can just say frag color equals vic3 noise large, vic4, vic3, is this possible? Noise large and 1.0. CMOVB assembly instruction conditional move construction. So we just need to so this sampler ID here, is there a way to like write that this is number 0 or something? Can you, or are they just in order? GLSL texture uniform locations. Is that a thing? Texture units in a sampler, texture 0. Oh, you can say what that is. Location equals layout location. Yeah, I know. I'm trying to like, on stream, usually I'll just be like, hey. In fact, I'm gonna ask. Oh, see here, it already wrote me out a whole thing about waves and stuff, but I'm like, dude, I'm gonna try and do this myself. For sampler 2D in a fragment shader, is there a way to set the layout IDs for binding? Do we know what that is? Oh, don't look at PBR. Look at this one. Run with, I don't know why it always wants to put VS Code in the mix. Yes, you can specify a sampler layout binding equals 0. Well, I guess if there's only one. But just so I can see. That seems like legal code. All right, thanks for that. So we need to, right now we're just going to see if we can sample this noise texture. The only problem is it's loading this model through the GLTF thing on each uniform. Right. Well, I'm more thinking about like when we do this GL texture 0, texture 1. Is that what this binding is? I guess I could just load the texture manually and not even load this model. I guess we do need to load the model. Usually you combine all those separate fields as one large struct for uniform values into one uniform struct. Okay. Well, I'm just going to try to keep it simple for now and see if in Blender actually I will bring in this texture and just use it as a usual GLB file like I have been using. Oh, here's a blade of grass. File, new, general. All I did was add a plane, triangulate that plane, apply, and edit another thing, apply. Have a plane. I need to create a new material, call it ocean. Add an image texture. From data train C++, res, textures. I'll get this pillar noise tiled RGB, put it in a base. And then set, I don't know, the roughness to like low. And this will load in this texture into the albedo channel, which is probably fine for now. Ocean plane.glb, save that, cancel. Okay. So that should all load, and it should load the material into the thingamabobber. I mean, and it will bring in what it will do. It will load that as an albedo map at texture 0. Whoa, whoops. So once we've got all that, we can not do any of this, but we will want to do the active texture ggal texture 0, right? This is the ocean albedo, which is actually the noise. Find texture, gl texture 2D, and the ocean object dot material dot albedo map dot id. Right, so we should be able to set that, and then do we need to, what do we need to actually set on the sucker? We need to set, don't worry about those for now. We'll set the color. It doesn't matter about the color either. All we really need to do is set the noise RGB, because we're just going to sample that. But we will need to do the other part of the shaders. Genie shaders, because we do these, we need to do mainly the projection. Oh, we got this. I guess we can get the shader as well. Shader reference ocean shader equals render dot shaders dot ocean shader ID ocean shader dot set mat 4, and we want the camera. Do we have the camera? Dot. Game camera dot get projection, get view matrix. We actually, sorry, this is like not exciting. View. Nice. And then we can set view projection, get projection. Don't worry about the lighting for now. That's all we need. And then we will just draw.
3, 2, 1.
And then we can just call draw thing, right? Come over here, friend. It's under graphics, of course. Graphics in it, and then render object. But we need to set the model matrix. That'll get set. Or we'll send it a model matrix. But we just kind of just want this part of it. This convert primitive type actually. We don't draw render object anymore, so this shader can be changed to the object dot material dot shader. Sorry, what? Oh, it's a pointer. There's no actual shader? What's the point of that? Oh, let's just do this and get the renderer.shaders.ocean shader, because I don't think we use this for anything else right now. But we will set the okay, so we can gfx draw render object, and the object is the object ocean object, and the map for is transform to matrix ocean xf. And the tint color is white. That's a legal call. I wonder if this will show me anything. I got a feeling that it won't. Yeah. Oh. Okay, the renderer still works, but we do not see anything. Do we load the... We do load the ocean plane. We use the program, we set the ocean object, we bind this. Oh, we never actually load the shader, do we? It's probably important. Shaders dots ocean shader. Shaders load res shaders ocean vertex shader res shaders ocean fragment shader. Let's see if any of this works. Do we actually load the shader? Hey, I'm seeing something. Hey, I'm seeing things. Wow. So that is the, yeah, and the thing moves with the world. I mean, moves with the camera, so that's gonna need to be taken into account. Hey, I'm happy that that actually worked. I wonder how would you tile this times 2.0? Would this tile it twice? It looks like it did. Sorry, it's on the wrong screen. Let's set this monitor to 1. So if I tile this by 5, oh yeah, it tiles, and buddy, it tiles. Ding 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 ding. Nice. So if I wanted to offset this by the world position, world space position. What if I just did like by frag position? .xz. Is that a thing? I think this is not a thing. Oh wow, it kind of is. Whoa, look at it go. Oh yeah, buddy. It's not as simple as that. I might have to ask Le Oracle. How might I sample my noise texture by world position as the ocean plane moves with the camera? This is the thing when you're in like Unreal Engine, or you just go world position. You just go world position. Dim 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 dim. Frag pos input. Yeah, I knew I was on frag pos. Oh, it loves to like go, oh, and you probably want to do all this other stuff as well. Just calm down. All I want to do is the one thing. World text coord. Frag pos xz. Okay, so this is just not using the texture coordinates at all. Vec2 world times 0.1. World text coord. Oh, it moves. It moves. Wow. And it will always be in view. It's quite hypnotizing. And then I guess we can do, I don't know how we want to, do we multiply them? Float noise. Chat disconnected. What? equals noise large times noise medium times noise small. Combined noise. Okay, the multiplier is not the 1. Plus. Okay, that becomes too bright. What are my other options? Well, things like overlay and things like that. Okay. So we got the world text quad. Now we want a new uniform called uniform float u time, and we want a u large wave large waves large speed and medium speed, and then game. I guess we can just. I never set the model matrix, did I? It's interesting. Why does it still work? Oh, it does it in the next step. My bad. Ocean shader dot set float u time delta. Do I have it? Should really be in here, right? Genie. Oh, it is time. Get. Oh, as a clock. Get frame time. Ocean fragment shader, we can say that we want to add this is plus time, u time. No, I guess not. Times xz. Let's say world text coordinate dot x plus equals u time. Will that do a thing? Not really. This is happening so slowly I can't see it. U time times 100. I've got an F in here. I don't know whether F's are legal. Successfully connected. So why is it doing that? The time needs to be accumulated. That's not per frame. That's just adding a little bit. Do I need to send it the actual clock? Elapsed, get elapsed. Dun, 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 dun. Yes. 0.1. We did it. We're scrolling, finally. I guess we need to sample this more than once, don't we? Oh, we could say world text coordinate. And then we could say that we want to float large sample x equals world text coordinate dot x plus equals u time times, and we'll put 0.02 for that one, and we are going to need to sample it multiple times. Are we? I guess we are. Medium sample x. Small sample x. And then we want to, yeah. Oh, that's annoying. I thought I was going to be able to take one nice sample. Well, it depends. No. Large. Vec2 world text coordinate dot x, dot y, and the large sample x. I guess we could, yeah, I don't know. Noise sample large, medium, small. Will this do a thing? Hey. They're way too fast. 0.02, 0.04, 0.01. And I don't know about this plus. What are some other blending options? What are some other blending options for putting this combined noise together? Ding 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 ding. Make me a shader. Expert. Oh, don't get too complicated, bruv. Screen blend, overlay blend. Float, overlay. Float base. This is, we're making Photoshop. Float blend. Return base is less than 0.5. Oh, it's got an if statement in it. Interesting. 2.0 times base times blend. Is this stream still working? I hope so. Oh man, I'm not gonna write this out. I didn't know overlay was so intricate. Float combined noise equals overlay noise large and noise medium. Combined noise equals overlay combined noise and noise small. What happens there? Oh, lovely. You can definitely see the little 8-bit-ness to it. Overlay is not the one we want. It looks like clouds. Screen. Da-da-da. Oh, lovely. Hey, this might be a nice cloud shader. All right. Thank you, AI, for helping with that. This is essentially what we wanted to do. Is the 3 sampling necessary, or is there some clever way to scroll the texture at different speeds using a single sample? Sometimes you just gotta ask, is there a clever way to do this? Because there's clever ways to do everything, but when you're not that clever, you... Ding, ding. I like this song. Bing, bing, bing. It's a rainy old day here in Sydney, Australia. So this, I mean, we could put those in, but we could also now create the actual lighting, but we will need to convert these to normal maps. That's the main thing. Come on, man. It's happening. It's happening, dude. So what is this? We were looking for GLSL convert height to normal. And we got some shader to where we're like, yo, this is just 3 lookups. Isn't it best to return a Vec 3? Both are good. This is more design POV. Inverse function. You are doing too many computations. This is the dude. This is the shader master here. This one is mathematically equivalent but shorter and faster. Only 1 normalization instead of 2. No cross product and less variables in flight. Right. To achieve the effect of multiple noise layers using multiple texture samples is the standard and generally alright. Okay. Calculated scrolled X coordinates for each layer time independently. Yeah, that's what I did, right? But I hard coded them, noise sample large. Yep. We could do an XY so they go in different directions as well. Okay. Next question. These are grayscale. These are single channels of an RGB image. Can they be converted to normal maps on the fly? And we'll see this. What is STE? We'll just steal this code. We'll go, what does it return? What do we need? We need a Vic4. Vic4 bump. Bump from height. And it needs to take in Vic2 UV. Does it need a resolution? Float scale. So this chappie says resolution is, we'll just do Vic2 equals st equals 1 dot over resolution. Do we need the resolution? 2048 is the resolution of this texture. Is this 1 dot thing float aspect equals 1 over 2048. Oh, here it goes. Look how hard out it goes. Okay, compute noise. Oh no, don't tell me there's a compute noise. What's compute noise? Get height. Return texture sample. I don't know what that means. I don't know what this means. Normal map from height map, OpenGL. Oh, this is out of my depth, out of my height. Blah blah, people talking about it. I guess we could just use this. This seems to do what we're talking about. And then maybe we'll figure out what thing says. Okay, float. Do we need this float get height, right? Which is a Vic2 UV. Return. Well, we're already sampling the thing. And it's just getting the, so we've got our samples, don't worry about that. Bump from height, Vic2 UV float scale. Okay, whatever. We get that. Step equals 1 point times resolution, whatever. We get that. Then the float height equals, well, we've already got our sample, right? Maybe we don't need the UV. Can we just have a float sample? We've got the height. Now Vic2 dxy equals height minus Vic2 it's got a sample around it. Okay. All right. Float get height. Vic2 UV. Turn texture U noise RGB dot at the UV. Oh, and this is This is based on, well, I'm trying to do it on a 3-channel image. Int channel. Shucks, man. How do I know how to do that? Maybe we just get the full sample and we split it later. Dot. We just get this, and this gives back the Vic4. Oh, this is confusing to me. Only because of these 3 things. Oh, top chat. Live chat. Okay, we're back. I guess this is fine for when we want. We could, okay, let's have 3 different ones. Get height R. Oh, but then we're going to need 3 bump from heights. Bump from. Let's just all inline it. Let's inline it. Don't worry about all this. We know what we're doing. So that's our sample. Oh man, this is... Okay, what did ChatGPT say? Large waves, medium waves, small waves. Okay. The UV delta, did it have this? Step. Okay. How does this look? I mean, it looks terrible. Man. This is another one. I guess it does like smoothing and whatnot, right? Should I just load 3 normal maps? Or just copy paste this thing? Base world text equals, that is the scaling. Don't worry about all this other stuff. Sucks to do this. I feel like we were getting somewhere. I guess instead of doing all this, we've got 3 textures in. Oh yeah, but we had other issues with normal maps, didn't we? Just a second. Alright. What happens if you make this? $20.50 by $20.50. And then you crop this by 2 on each side. We improve the tiling. There's still kind of a line, but yeah. Oh, why is this? What's this 2046? Do we need to crop this? Don't crop it. Oh, these are 2050. Crop by 1 on each side. We got a little line. Looks pretty good. It's weird that it's doing this little squares. Ocean normal map large. Okay, we'll just go with the 3 normal map method. We'll try this. Come on, baby. Small. Oh, that's a problem. Well, I guess they all get brought in as full textures. So you can say the base color is the normal map large. This is gonna get did I put a thing that makes the did I put a thing in that forces it to be PBR.fragment shader? I think I do it. Oh yeah, I do. I convert the color tint. Oh, that's the color tint. I think this one gets brought in. Albedo map. I do this load texture from sRGB. Oh, I guess we've still got 3. We've still got the metallic, the medium can go into the normal map. Oh, this stuff is annoying. This could go into the emission. Or I could just load these textures and not bake them in. I guess I could just load these textures. Maybe that's a better way to do it. Game. So I could just put in what's in the model data? Texture. Oh, there we go. We can just put in ocean normal map, large, medium, small. And then in game models, we'll just load them. We'll go G-game, models, ocean, map large, equals, textures, load, and that just wants a file name, res, where is it? Where is it? Models, textures. No, it's not in there. It's in res textures. Okay. Res textures. Ocean normal map large.png. Okay. Come on, man. Do my bidding. Okay. So we load these. We move to the fragment shader. I'm going to call this unoise normal large. Binding 1, binding 2, medium, and small. Large, medium, normal, small, normal, large. Okay. And then we'll just render the noise sample large. And we need to do something to it to push it into the right. The normal map times 5 plus times half plus a half. Okay. So in the game, we will set texture 0. This is now not ocean albedo. This is ocean normal map large. Bind texture. models dot ocean normal map large dot id. Normal map medium, medium, small, okay, is that enough? Oh yeah. It is. Fragment shader, sample small. That one's moving the most. I think it's moving really slowly. Something loading is taking too long. There it goes. Hey, buddy boy, yeah, buddy boy. I think we just leave it like that. I think it's just a look. Okay, so we got our different noises, and we don't really want these values anymore. What we want to do is do the rest of the shading, which is all this madness. So metallic equals, we're gonna put in roughness ourselves. So now we need to do the normalizations. Vic3n equals normalize the V normal. I wonder how we're going to add them together. Sample normal map and decode it. Vic3 normal map value equals texture. Oh, we've already got that. Well, we got that one. I guess we need to say noise sample large equals normalize sample large times 2.0 minus 1.0, right? mat3 tbn equals a mat3 normalize the v tangent, normalize the v bitangent, and normalize the v normal. Whoops. Go away files. Let's go smaller a little bit. N equals normalize TBN times the noise sample large. Now we need lighting vectors. I guess we can just copy this stuff. The metallic factor, this is going to be, I don't know if we need all this because metallic's always going to be 0. Specular, blah, 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 blah. I guess we'll just do this full full noise. Vec 3 emissive equals, I guess we just don't need emissive. Vec 3 tone mapped equals linear color, and then output the tone mapped color. See if this gives us a deliciously normal mapped thingamabobbles. Okay. Oh, we've got to set some things in here. We want to set some. Let's move this. Here, and we want to also have a local persist. What do we need in the ocean? We need to set the roughness. If 32 ocean rough equals 0.2 F. So we'll set that. Oh, we need to set all this stuff. And the color. Local persist color ocean color equals color aquamarine, which isn't a nice color. Maybe in shaders we can just set these uniforms over here. Shader reference ocean equals g renderer dot shaders dot ocean shader gl use program. Oh, we're just gonna be careful because we don't. Okay, yeah, we're all right. Use program ocean shader dot id. I guess we could do this, but we'll just set the parameters here. And just check we have all these: light direction, light color, light intensity, camera position, ambient, light color, ambient, and light intensity. So that will set those. Oh, we want to maybe do this first. Game, ocean rough, let's set the ocean shader dot set float u roughness to the ocean roughness. U roughness, yep. Time is set. We'll set the color as well for U color, ocean color. And then we can make some little tools. Is this you can have a slider float ocean roughness, send in the ocean rough from 0.0f to 1.0f, and then we want our IM GUI color picker 4. Is this where we need to like send in ocean color? And I can't just send in the Can I say GLM to I'm GUI ocean color? I guess I can I am GUI I am Vic 4 I am ocean color equals oh, this is annoying. We have to like convert things back and forth. GLM to I am GUI ocean color. Doesn't like this. Color picker 4. I do want a color picker 4. Ugh, I remember this. It was a float I am ocean color 4 equals ocean color dot R ocean color dot G ocean color dot B ocean color dot A. Do I just send it straight in? And then we need to send it back. R equals I am ocean color dot R. Oh, can we just say I am GUI to GLM? No, that's not going to work either. Color dot R equals, oh yeah, it's I am ocean color 0. Okay. Right. So that should give us the ability to change stuff. Oh, beautiful. There's this lag when it's loading. Okay, do we have our little game test debug? Bzzzt. Ocean color. Oh yeah, something delightful like that. How does it react to the light? It reacts nicely, I guess. Wow. Beautiful. We can really see those 8-bit values on the ocean. Can we use 16-bit values on the ocean? And the ocean roughness, that works too. It's very not rough. Give it a real dark, rich color. Yes, there it is. Okay, now how do we combine the normal maps? I want to know. That's what I want to know. Oh, we don't do any tone mapping. Why did we not copy the tone mapping over? Do I not do tone mapping here? Oh, tone mapped color. I forgot to do all this. Final color. Okay, this is beyond my pay grade, so I'm not sure if there's anything fancy I need to do. Is it possible to layer noise maps together? Thinking. Are we still live? That would be not cool if we were not live. Oh, don't make any noise. Oh yeah, it's still working. All I really wanted to know is, whoa, why is this all rewriting the whole thing? All I was... Combined equals, you just add them together. You just add them together. That's what I'm seeing. Sample large. So we've got to normalize them all. Small. Then we want to do a vec3 noise samples combined equals normalize noise sample large plus noise sample medium plus noise sample small, and then sample combined. Noise samples combined. Was that what you were saying? Is it saying correctly calculate independent scrolling textures, but trust treat each sample as tangent space. Unpack these normals, combine these three trends using a robust TBN matrix. We only work with robust TBN matrices. That doesn't look right. Oh, but maybe it is. It looks kind of like wrong. The ocean. We made the ocean. A one-to-one ocean. Oh, there it is in all of the beauty. Just how the ocean looks in real life. Yeah, buddy. Just scrolling through the world. not reacting to anything. It's funny how it just doesn't look right unless it's got a little lighting on it. Roughness to 0, or interesting. Yeah, on a funny angle, it just looks like paper. Zoop. I guess you need some sort of transparency interaction with everything. You can move it up a bit and then draw it last. What happens if we move something in the other direction? Like these little ones go the other way. Oh, it's going to reset that thing every time to this hideous color. And also the lighting angle is a bit funky. How come? Oh yeah, there goes the sheen. So it's like, if that's straight down, we don't get much. Oh, premium. That's really funny, the ripply effects. Look. Like you kind of know what oceans look like. Oh, the dark, deep darknesses. Cosmic. Oh yeah, does it have some roughness levels? Cool beans, man. Render frame. Does render frame at the end of render frame? Oh, we GL swap buffers at end frame, so we can still render this thing after render frame. Can I just cheekily chuck that there? Between render frame and end frame. And this color's bad. I don't know, dark blue. I wonder if there's a way to like change the... Oh no, we lost it. Oh, we need to do the whole process. We just do all this ocean stuff down here. I wonder what happens when we change the opacity. Nothing right now because it's not quite high enough to do anything. Oh, that's lovely color. How is that dark blue? That's like dark blue to the max. Blue. These are all just intense blues. Deep sky blue. What was I trying to do? Oh yeah, move it up a little bit. Position equals Vic 3, 0.0. Oh, and every frame we're making it position, I guess that doesn't matter, but what does matter is going ocean xf dot position dot y equals 0.5. 0.25. 1.5. Down. Wow, wow, wow. Deep sky blue. Okay, now there's a little, it's on the world a little bit. Also, we can change the alpha. Well, we don't actually take the alpha into account, do we? There's our ocean. And it moves with the camera. And the world visitor gorgeous, I love it. Oh yeah, there goes some. Okay, we need to sample the alphabet. Of the. Alright, here we go. U color, let's just get it straight from the source. Inspecting. There it is. And that, my friends, is a perfect ocean simulation. We really need to fix the way the light angle's calculated. -1, -1, -1 is just... Yeah. Oh, the noise scale would be good as well. Oh. You need a little edging or something, eh? Hey, Alex, are you still there? Do you know why, like, this... I don't know if you can see this. Can I zoom in? What's happening? I just lost my... Whoa, didn't like that. Yes, indeed. I just broke the whole thing. Oh, there we go. This, is this just like Z depth testing issues? When you're at like far distances and it just doesn't know what fragment's in front of the other one. Yes! I'm gonna take that as ocean victory. 2 hours, 39 minutes to ocean. Oh, I could do the ocean. I could put a few more controls for the ocean speed. Also, you could have these blocks go down and do like a depth map thing there, I think. But first, we'll get a little low angle sunset, ocean sunset will get low light, get a little low angle. Yeah, a little low angle. Do we get any ripples on the sunlight there? Oh, thanks. The ocean's looking fantastic, man. I mean, this was a kind of a slightly custom-y ocean. I like that little flat shading look. We kind of cooked it up. I don't know how to force. We just have to be at a deeper angle to be able to see the sweet lighting on the thing. Reflects the sky. Oh, that reflects the sky. The cube map. You're correct. Where are our camera controls? Oh, yeah, and be in this sort of zone here. The FOV, mates. If I made the ocean real, oh, I can only get a 50. Alright, forget the low light. We need that super angular light again to get oh yeah. Daisy Lib. This is, I ended up kind of removing Raylib and stealing little bits of it. Not stealing, but you know, open source researching. And then did an OpenGL implementation and wanted to do the shaders and stuff manually. You can see the crusty normal maps there. With the little 8-bitness. I wonder if, I'm sure you can load 16-bit stuff. Let's open container test. Oh no, we're not in release mode. This is going to destroy. Let us go into release mode. Harness the full power. Oh yeah, we could also put in some more things. Local persist. What did I want to do? The speed. The roughness. What else is there in this fragment shader that's cool? The wave speed, the color, the roughness. Was that it? Oh, the scale factor. Uniform float U scale factor. Times U scale factor. F32 scale factor equals 0.1 F. Large wave speed, medium wave speed, small wave speed, next C++ portfolio piece will take inspiration from my direction. 3D shaders coded without engine is exactly what I need to do, but one small project at a time. That's right, and even each small project is made up of many other small steps. But it is pretty cool to having all these little things that start to come together. 002004001. Zero one What are these things called? U waves large speed. Waves speed large, medium, small, and this can be large wave speed. One thing I'm not quite getting yet is like just doing all this stuff each time, you know, just making the thing you want every time, and trying not to think of things too much like, oh, how do I build a system to then do this in lots of different cases? I think that's missing a little bit, and it would be good. But also, I'm starting to think that like too much genericism in your thing, in your app, to try and just handle all these different cases, maybe not the one. Especially, I don't know, maybe it's a maturity thing. Like as it matures, you start to see the patterns of things you're doing over and over again. You scale factor. Whoops. Scale factor. Is that right? Scale factor. So we're using the scale factor, but we're not using the waves large speed, medium speed, small speed. Like it's interesting to do this, like having different shader setups and how they work. I guess you could cache all these names and things. I don't know how to generify it. Yeah. Sometimes I'm just like, just write the thing you want when you need it, you know? Like this whole thing here is like the shader, the whole ocean. It's right in the middle of the game loop, in the main update loop. But this will go somewhere. And then I'll see, oh, maybe I can make these a little less like low level, have some calls to like activate texture or whatever, bind texture, I don't know. Kind of depends where, because when it's your project, your mindset is in the depth at which you're comfortable. At some point, maybe you don't want to be in that depth, you want to be in the gameplay layer, and you just want to say, do a thing. You can't always be in the systems layer, but maybe you can always be in the systems layer, I don't know. Large waves speed, medium wave speed, small wave speed, large wave speed, small wave speed, medium wave speed. This needs to be like multiplied. Wave speed. Let's, before we do this, do like large wave speed times equals 0.01 or something. What am I listening to? Yeah, I mean, this is in the world of like, you're the sole maintainer of this project, you know? Guess if you get to the point where other people are involved, this is still quite small numbers. Maybe we times it by 0.01, is that right? We'll find out. We need to just use these numbers, don't we? Oh, we did do that. Is that what we need? Ding, boom, ba-da-dum, boom, boom, boom. Oh, we're in release mode. Ocean, calm yourself. Yeah, give me some of these. Oh, it just keeps getting set to 0. Oh, is that because it's static? I guess, oh, we just do this here, times 0.01f. Don't want to do that every frame. Tips on Raylib. I tried it once, big learning curve. I think Raylib's pretty straightforward. I learned a lot mainly just by looking at the examples. Oh, these things are too high. These need to be by 0, 0, 1, and these just go from... Yeah, the learning examples are really good. 0.1 to 50. That's 5, right? What language are you using? Oh, lovely. There's only one thing is I have to keep resetting this every time. Wowzers. Look at these hideous normal maps. It's almost like the small ones don't really do anything. Small waves, medium waves. Why does that seem to affect the medium waves? Go large waves. They need like weights or something. C++. I thought about doing Zig on a later date. Yeah, I found working with Raylib and C was a pretty good combo because it's all in C and you're kind of just in C land. And then once you got C, then like you can kind of go anywhere from C, I feel. Might not be 100% right. Well, let's get some better defaults. Raylib is cool, yeah. It is very cool. Wowzers. Yeah. Open the container test. Can we do it? I don't know what happened to my... I must have done something because this used to be like 300 frames a second. Now we're down to like 170, 180 for 100K containers. Yes. Dun, 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 dun. Sky reflection will make a big difference. Yes. PC specifications. PC is one thing at a time. PC specifications. This has got a 3090, so that does help. But I did run this on the laptop, and I was able to get over 100 frames a second on an older laptop with like a 2070 or something in it. And it's a 14900, I think. I built this bad boy for video production, but it seems to be good for games as well. Yeah, I know what you mean about getting comfortable in the space. I try to force myself to like do things multiple times, like make a little prototype or make something, and then make it again in another framework or another language. Like this Daisy Trains has been made in C++ and Raylib, in C and Raylib in 3D, in C++ and Raylib in 3D, and in C++ without Raylib in 3D. And it's kind of like there are so many things that cross over, I guess. And this is just me, and my fiance Lou helps out with some of the artwork, but she's also got a job, so she works full time. Whoa. Yeah. So we need a cube map and Odin, yes. Oh, and Odin, yeah, and we did a little work in Odin as well. Odin's another good language. I just wish there was more info on it. And the doggies. Where's my doggies? Oh, they're so sleepy right now. I need a dog cam. I should hook up a dog cam. That would make the stream views go through the roof. Yeah, the dogs help a lot. I might just grab these light angles. This is the only way I have to serialize my setup, is to why won't you let me view you? I can't actually save my settings right now, so I take screenshots and then handwrite them. Nice. I'm quite happy with that ocean to begin with. It'll be cool once we've got like depth sampling. Oh, we've also got this alpha. Once there's depth sampling, yes, the cube map. Oh yes, you're talking about the interop. Yeah. I mean, I just try to always look for the parallels between, you know, like computer science is pretty complicated, but there are like ways to, I mean, finding like commonalities or something that you can take across what it is you're working on or something. I don't know whether Perlin noise is really the one, but on that is alpha. Yeah, I think like once you get into like, once you've got a depth map, you can make this depth look deeper, and I might extend these levels down further. So the bottom layer draws like into the ocean, and it looks like it goes deep, man. Oh yeah. I was imagining this game to look really like lo-fi, But we're getting like into the hi-fi fidelity. Oh yeah, cube map. That's what we need. We need a cube map. Ocean can get a work in progress. To do sky map. Or you could just, rather than be fancy about it, I guess you could just have it reflect a sky color. It'd be cool if it had some sort of translucency. Grass. I tried some grass stuff. It didn't work. Tunnels. Trees. We have trees. Maybe in game. Oh yeah. What are those? Enemies. Gallery. What were those settings? I need some more robust serialization of the game state, the engine state. Shaders. So the light directions is the default. Negative 0.932. Negative. Oops. What else do we have? The wave scale. Foam line around the islands. Yes, you can do that. I think you can do that with the depth thing as well. So you get a little bounce back or something. A little interaction maybe. So this is set to 4. This is set to, we'll set this to 10 and 8. Oh. That's, oh, the scale factor. I forgot about the scale factor. I never put a little thing in for the scale factor, did I? So this is annoying, the ocean color. Doing this R is 0.0 F, B is 13.0 F, wait, G, 13 point over 255. Blue is 23. Oh, he's back. We 0.7. What's your theory on how far we got on the ocean? Do we have a glorious ocean? Oh, scale factor. We do have scale factor. Let's find out. Oh. Wait, where's my sweet? Oh, yeah. Little blocky looking guy. Oh, yeah, there it goes. Wait, where is the scale factor? That should be... Is this negative? I think this one's negative. Oh no. Foam, depth green, fishes, physical waves, hitting island, sand depth. We're going to simulate every grain of sand. Let's not stop there.
Sometimes we just do it. We just do it. And then see what happens.
Oh, I never made that one. Waves. Scale. Scale factor. From 0. We'll just go from 1 to 10, and then we'll do scale factor times 0.1f. And we'll set the scale factor to 1. We got some blue. Yeah, we got some blue. I don't know why we... Oh, there it is. The roughness looks a bit better like that. Wave scale. Oh, it's hard to know. Oh, look at this little sunken dubious. How easy is it to tell it's tiling? Oh, it kind of looks like the way where... Let's get some trees going. No, that's a port. Trees. Oh, that's kind of cool. When you make the level, it looks like it's in the ocean. I'm thinking of outlawing slopes from the game and being able to build rail up like that. Oh, you can certainly see the tiling. Make them bigger. I think it looks better when they're smaller. I'll take things that don't matter for 10. Zoop. This is a strange lighting angle. Okay, accepts only orange. Oh, I don't have that. None orange. And then this one accepts none, only yellow. Supplies none. Supplies none. And then sometimes go that way. Whoa, dude. Are we ever going to get rid of our ones? Supplies all. Get rid of them all. Oh, it doesn't. Oh, yeah, we have to. Or maybe we just get a little boat going for the Jolinos. We've got to put a boat on the water. What are we doing if we're not putting a boat on the water? Beep. And one here. Beep. Beep. Connect. Little boat in the water. Is it actually in the water or is it hovering? It's hovering quite high above the water. Yeah. We need that to draw a little, now it needs to draw little wakes. Flat shading looks pretty good actually. Yes. Yes, it's all coming together. Whoa. All right, we've done 3 hours. Pretty happy. The title did say the ocean, and now there's the ocean. Is there a feature that can't be implemented in 3 hours? Let's get some wave speed going. And now we're, whoa, yes, perfect. Oh, it depends on the scale factor as well. How rough is the ocean? I've definitely seen it look like that in some games, eh? The OEN. The OHEN. Kind of like it with a little roughness on there. Ambiance. The ocean. The ocean. That reverb is not good. We're gonna have to fix that reverb. I want long reverb. It's not very oceanic reverb. Yeah, that looks better actually. I like that. What happened? We changed a bunch of stuff. Ocean roughness. We'll set that to 0.2. The wave speed's quite nice, high as well. Effects. Let's bring this up. Where's my thing? Pad settings. Oh.
Itty bitty living space. Phenomenal cosmic powers!
Phenomenal cosmic powers. So, it's this thing. The FX1. Yes, the reverb. 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 Oh, we need a high pass filter. Yeah. 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 The ocean. That's much better. Oh, we've got incomplete data here. This one connected this. Oh no, I did it. I did a mistake. These drains. Wow. 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 Yeah, it needs to reflect some skylight. Alright. I think I might call it there. After we've just implemented a physically accurate ocean. What are these two boats doing though? I feel like we're ready to start with some test levels almost. Got enough bits and bobs. Daisy trains. Alright, y'all. Alright, everyone. Thank you for tuning in to this stream about the physical dimensions of oceans. We need to communicate trains across the ocean. Maybe we need, like, trains that go on, you know, like the Spirited Away train. The Sea Railway. This guy. Oh, that's probably in the wrong place. This guy.
Phenomenal cosmic powers!
Whoa, what's that one? Thanks, Jess. How's the dog? Any word? Any news? Can't end the stream until I get the news. If it's bad news, we all good? We all good? Unless you're already gone, in which case. Well, if you're already gone, keep us updated in the old mate in the Discord. That goes for anyone who wants to come chit chat nonsense in the Discord. What? Oh. Surgery went well, but they're keeping him overnight to keep an eye. Okay. Whew. Do you consider streaming as eventually good for the making of the game? You know, it's funny, I was talking to my partner last night, and because Monday I streamed, and then Tuesday I was like, I'm not going to stream, but I worked on the game. And actually I was like, kind of you think that streaming is going to be like, make progress harder? Because you got to focus on streaming and all this stuff, and then you feel dumb if you don't know what you're doing. But then it's weird, it kind of puts a little bit of pressure on you to be focused, be in the moment, work on the problem, you know. So it is like going to work, I guess. So it does help with, like today I was like, oh man, why am I writing ocean shaders? This is so lame. But then it was kind of like, and it came together, and yay. Whereas yesterday I made a tree planting algorithm, then I messed around with grass, and then I kind of just gave up, you know. So being on stream actually helped. Jesse, I hope for the speedy return of the hound. Oh look, there's one here. Yeah. There's just one. Oh. There's one here. What's this over here? Over this side. Up there. That's you, Beansy. She can see herself. She can see animals on the screen. Yeah. Thank you. Yes, thank you. Thank you. Oh, you got sleepy morning breath. Delicious. What's this one? What about the other dog? Oh, good girl, Beansy. Oh, sorry, you're all tangled up. I know you don't want to be scooped up. What is happening? It's happening. Oh, another one. Look at this dog. It's like a cartoon dog. No, don't do that on stream, Chili. That's not the one. Oh, buddy boy, look at these paws. Yeah. Thanks, buddy boy. This is Tabasco. He doesn't like being picked up. Do you, buddy boy? What do you think about this microphone? What's this one up here? No, good boy. You can run away if you want. Alright. Well, all the best. Thanks for coming and dropping into the stream. Chit-chatting. Keeps the morale high. Great things are on the horizon of the ocean. Maybe with a little delay. Yeah, cheers. Thanks so much. We'll catch you guys on the next one. I'm going to keep up the streaming tomorrow. I'm committing now to tomorrow. Let's do it. All right. Catch you later.